This section is about derivatives and rate of change. So let's start with reviewing the concept of secant line and tangent line. This time I wrote everything beforehand because I don't want to mix up the concept and the order of them. Okay, we have a curve. So the curve of the function, the curve is function f of x. All right, so we have a y curve. So that is represented by f of x. I have 2 points on the curve, a point P and a point Q. First, I build a secant line between P and Q. So what is a secant line? Secant line is the green line. So look at the green line. That is called a secant line. Secant line means you shoot a line through the curve and there are two intersections. The purpose of doing this is I want to find the slope of point P at the curve. So this is a curve, right? So that means it's not a straight line. So not a straight line means the slope is not always the same. So the slope is changing all the time depending on which point you pick on F. So this time I pick P. I pick point P. At point P, there is a slope. But if you just give me a point P, I am not able to find the slope for you because to find a slope, I need 2 points, right? So that is the concept we learned in algebra. Fine. I'm going to give you 2 points. I start with a secant line. I shoot a straight line through the curve. There are two intersections, point P and point Q. So at point P, the coordinate is a comma f of a. Why is that f of a? You plug in a into the function, right? Then you get f of a. F of a is a y value. And then point Q, you plug in x, and any x, you plug in an x value to the function. So the x coordinate is x, the y coordinate is f of x. So look at the green line again. It is a straight line. What is the slope of a straight line? We do y2 minus y1 divided by x2 minus x1, which is rise over run. So in this case, our y2 is f of x, y1 is f of a, x2 is x, x1 is a. So you do that, you get a rise over run. However, that is only a secant line. Secant line is two intersections. That is not what I am looking for. I am looking for a tangent line. What is a tangent line? Look at the pink line. Tangent line is one intersection. It's a straight line that touches the curve one time only. One time only means one intersection. How do you go from a green line to a pink line? From green to pink. From secant to tangent. To go from 2 points to 1 point, all you have to do is you shrink the distance or you minimize the distance between point P and point Q. So look at the tangent line, look at the second graph. Tangent line is one intersection. I want to make Q approaches to P. By doing what? By minimizing the distance between P and Q. So that means we have to minimize the distance between X and A, right? So this distance is what we have to minimize. We have to minimize the distance between X and A. Once X and A are, the distance between them is minimized, so point Q, you just like move to point P, right? You shrink the distance, so you are making 2 points to become 1 point. So the secant line becomes a tangent line. All right, then what is the slope of the tangent line then? So since you are trying to minimize the distance between P and Q and you want to let X approaches to A, so X approaches to A, so that means when you write the slope, again, you have f of x divided by f of a, so the top no change, but the bottom, x minus a, looks like there is no change. However, you are trying to minimize the distance between them, so you have to let x approaches to A. So when X approaches to A, that creates a problem. What happens when you put X into A? So you have X minus X, or you can say you have A minus A, right? So A minus A, what do you have? You have a 0 in the denominator. So that gives me a trouble. So that's why I have to do limit. I have to everything I can to the algebra to evaluate the limit. So let's go to the third graph. Again, what we did so far is we minimize the distance between X and A because we want to let point Q approaches to point P. So we can make 2 points to become 1 point. So we go from a secant line 2 points to a tangent line 1 point at point P. So let's look at the next graph. So we have point P and point Q. This time I am going to call the second point A plus H. So I start at point P. I am trying to build a secant line. I shoot a straight line through the curve. So we have point P, we have point Q, we have a green secant line. So what about the point Q? The point Q, I am not going to call it X anymore. Here is how I am going to interpret this. I start at point P. The coordinate is A comma F of A. And then I take H steps forwards. Again, I take H steps forward here. I take H steps forward. So starting at A, and then you add H to A. So you are taking X steps forward. So to get to my next point. So the coordinate of the X coordinate of point Q is A plus H. And then you plug in A plus H to the function to get F of A plus H. So now I have the coordinates of point P and point Q. And then you use the same technique. The green line is only a secant line. You want to minimize the distance between P and Q. That means you want to let Q goes to P. So that means you want to minimize the distance between A and H. So what is minimize the distance between A and H? That means you want to minimize this H. Minimize this H, simply you just let H goes to 0. So this time when you write the limit, the top is A plus H, because we are using point Q minus point P, right? Y2 minus Y1. F, this is a Y2, this is a Y1, this is a X2, this is a X1. So when you do Y2 minus Y1, you have F of A plus H minus F of A. What about the bottom? The bottom is A plus H minus H, which is equals to 0. So that satisfies what we are trying to do. We are trying to minimize the distance H, right? Therefore, you just let H goes to 0. So when H goes to 0, then this H is minimized. Then point Q will just shift to point P. So therefore, we start with 2 points on the secant line, the green line, point P and point Q. After you minimize the distance H, the point Q will just shift to point P. So we just make a secant line becomes a tangent line as long as you let H goes to 0. And then after that, we have a tangent line, right? Look at the yellow line. The yellow line is a tangent line. So the tangent line touches the curve one time at point P. The slope of the tangent line is the same thing as the slope of the function f at point P. At point P, there is a slope. I am using the tangent line, the straight line, to estimate the slope of the curve at point P. Because the tangent line and the curve f of x, they have the same slope at point P. All right. But what if you change the point P to somewhere else? If you change the point P to somewhere else, then you change the slope. You change the slope, then that means you change the tangent line. All right. So there are two keywords in this section. The first word is displacement. So what is displacement? The displacement is length or distance. So let's say your house is in point A, your school or your workplace is in point B. You walk 10 miles to your workplace. So that is your displacement. You move from point A to point B. What's the distance? The distance is 10 miles. So 10 miles is your displacement. And what about velocity? Velocity is how fast something or an object moves in a particular direction. So when you walk or drive from point A to point B, how fast did you move? That is velocity. And then velocity, how fast something moves, we can use another word to describe that. That is called the rate of change. Rate of change. Okay. So rate of change in this section that links to another vocabulary called derivative. Derivative is a huge keyword in differential calculus. So basically the whole purpose of doing differential calculus is to understand the derivative and study the application of derivative. You need to know how to do it, and then you apply that to some application. So derivative means rate of change. All right. So displacement, distance, 10 miles. The distance between 2 points. All right. So velocity is the rate of change of displacement. So displacement can be represented by a function, and then velocity can be represented by another function. To get to the velocity function, you have to find the derivative of displacement. So what is derivative? Derivative of function f at point A. So let's say we have a function f of x. All right, we have a function f of x. What I am looking for is I want to find the derivative of this function at point A. So for derivative, assuming this is your first time studying derivative, we have to use another math notation. We call this f prime of A. So f prime, so prime, the word prime is here. Prime stands for derivative. F prime of A is equals to limit s of a f of a plus h minus f of a, and then the denominator is h, and then we let h goes to 0. The top is y2 minus y1. We have the y coordinate of the second point minus the y coordinate of the first point, and then divided by x2 minus x1. So since for the 2x coordinate, we want to make point Q goes to point P, so we say we are trying to minimize the distance. The distance between the 2 points is called h. So now we have h goes to 0. That means you have a 0 in the denominator. So 0 in the denominator, you have to open up the numerator, do all the possible algebra to get rid of the h in the denominator. Again, the notation is called prime. So prime means derivative. Derivative means rate of change. Rate of change means the slope of a curve at a certain point. So we have displacement. Displacement is a function. So let's say displacement. You have function f, and then you can find your distance at time t. So instead of x, we are using t. And what about velocity? Velocity is you take the derivative of the displacement function, and then you treat t as an independent variable. Okay, I'm going to show you how to do it in another video. So let's go to a very simple example of derivative. So let's say I use some simple function f of x equals to x squared. X squared is a parabola, and then x squared is a parabola, so we have an orange parabola, and then I pick 3 points, one at -1, one at 0, and then one at 1. X equals to 1, 0, and -1. How do you find the derivative? I am going to skip that step for now. So for the derivative, this time I will just give you the derivative, the f prime of x. The f prime of x is actually equals to 2x. Don't worry about how I get the 2x. It is 2x. The derivative of f is 2x. Don't worry about how I got it. I will show you that in another video. So that is the derivative. Now, this is a parabola. It's a curve. It's not a straight line. So that means the slope is changing. The slope is changing. If you look at the piece where when x is less than 0, the tangent line, the straight line is going downhill, right? So the slope is negative. If you look at the piece where x is greater than 0, do you see that the tangent line is going uphill? The slope is positive. If you look at the vertex at 0, 0, the tangent line is horizontal, so the slope is equals to 0. Can you find the slope for me? So at this point, at this orange point, there is 1 point. Based on what I learned in algebra, if you have 1 point, you cannot find the slope, because to find the slope of a straight line, I need 2 points. But after you study this, all you need to have is 1 point. So first, you find the derivative. Don't worry about how I got it, just take it from me. F of prime of x is equals to 2x. And then when x is equals to -1, so when x is equals to -1, what is the slope of the parabola equals to? The slope is f prime of -1, so you have 2 times -1, that equals to -2. So that means when x is equals to 1, the slope of the parabola is equals to -2. -2 is also the slope of the tangent line when x is equals to -1. What about x equals to 0? When x equals to 0, the slope f prime of 0 is 2 times 0 equals to 0. So the slope of the parabola at x equals to 0 is equals to 0. So that means you have a horizontal tangent line. Still remember this, the slope of a horizontal line is 0. But what about 1? When x is equals to 1, so x is equals to 1, you have f prime of 1. So at that point, tell me the slope of the pink line. Tell me the slope of the parabola at that point. So at this point, tell me the slope. The slope is 2 times 1 equals to 2. which is positive, right? Positive means the line is increasing. Yes, this line is increasing. So that means when x is equals to 1, the slope of the parabola is equal to 2 because that slope is the same as the slope of the tangent line at that point. So that is the basic concept of derivatives, rate of change, and the limit. So in the next section, I will show you a couple more examples.